Okay, welcome back to my channel. Keep learning, your study partner. Okay, how are you doing, guys? I'm hoping you're so well this day. So, in this session, we're gonna discuss regarding the P&ID review. So, the P&ID review is needed since you work in EPC industry, maybe in engineering, procurement, and construction industry. So as a process engineer, you have to do the P&ID review meeting in your first stage of your submission of your document, especially for the piping and instrumentation diagram. We call it as P&ID. So I'm going to share regarding the how we develop for the P&ID. So in this session, I will share you about how we have to develop the P&ID for the heat exchanger, the cooling water exchanger, and the fan gas exchanger. Okay, so this topic is regarding P&ID review for the heat exchanger, flushing, and the instrumentation. So in this case, I'll provide you the sketch of the heat exchanger, cell and tube of exchanger. So as you can see in this exchanger, we have two sections in here, one cell and one tube. Okay, so for the tube is in N1 and N2, and the cell will go from N3 to the N4. So I will draw it. So this is the fan gas line. So this is the fan gas line. 04, this one. Okay, the flow will come here. Okay, and the cooling media we are using is the cooling water. For the cooling media, the cooling media will pass through the N1 because this cell and tube exchanger is work by counter current heat exchanger. So the cooling water will pass like this and it will coming out like this. Okay, so I have to explain you regarding the when we are discussing about the heat exchanger in the plant activity, we need to consider also when the heat exchanger is come dirty, especially for the tube exchanger, because this is the cooling water here, cooling water supply, and this for the cooling water return. So we need to ensure that the tube, the part of the tube is cleaned out by the backflush. So I have to redraw it to ensure that the bypass is accommodated in this station. Okay, so basically we're using counter current tube exchanger because it's work very well, since the heat transfer is good enough rather than the co-current design. Okay, I will erase the first for this one, and then we need to redraw. Okay, so this line is normally no flow, because the normally no flow is using for the just backflush for this SH changer. The normally no flow is indicated as the NNF for this one. So maybe it's just it's better if we have to this normally black, this shall be black color. Okay. So and then since the flow of the cooling water will go through and come into N1, so we need to ensure that this is have enough drain in here. Okay. Then normally the cooling water supply will circulate for this one and go to the for the N1. Okay, and then I will ensure that the cooling water will circulate on the tube inside and will come out through the N2 in here. Okay, so the normally flow is for the N1, N2, and this one. Okay, so we have to consider for the flush line, since this is the normally no flow, so we have to revert back for the flow. So this one, and this one. Okay, so we need to add a block fluff in here. So we need to add the block fluff in here. Okay, I add for the block fluff here. Okay, and then I have to add also the block fluff in here, because this block fluff used as the blockage of the flow inside coming to the N1. This thing. Okay. So during the backflush for the SH changer, we have to open the backflush line. It shall be open, and then close this block valve, so the water will circulate reverse as the usual, and the normal operation is the normally no flow, and then will come here. Okay, so we need to also close this block valve, and then where for the final outlet of the cooling water during the backflush, so we have to ensure that the drain connection also provided in here. Okay, so we have to add drain connection in here. Okay, the drain out connection is provided, so we have to ensure that the drain connection is in open position. Okay, so we have the backflush scenario on the P&ID, so we have to ensure that our P&ID has addressed this backflush facility. So this in normal the bypass valve is shall be in black color, because this normally no flow. Okay, we'll go to the next question. So for the instrumentation, the basic instrumentation for the PI, the basic instrumentation for the cooling water line is basically for you have to measure how much the pressure that you have in your cooling water line. So we need to ensure that the cooling water inlet have some PG in here. Okay. Yes, as you know that the cooling water is quite dirty rather than the process fluid, so we have to install 2 PG in here to ensure we have the value of the delta P or pressure drop inside of the tube of part inside of the inside the exchanger. And then we have to put also for the temperature gauge in the outlet of the cooling water exchanger, because the heat exchanger is also done by the temperature gradient. Okay, I have to install TI in here or TG, because TI is much expensive rather than the TG, because it's just cooling water, so I need to consider just for the TG. Okay, so we can see if there is abnormal situation inside of this exchanger. We can observe for the TG and we can compare both of the PG, and then we can calculate of the differential for the BG1 and the PG2. So then as a result we have delta P, PG1 or PG2 and PG1, and also for the TG we can observe for the temperature itself. Okay, for the next this is the process fluid stream. For the process fluid stream, because the fluid stream is much clear or not dirty if comparing with the cooling water session. So the PG has to provide on the discharge is okay, just on the discharge of the line. Because you have to know that there is no clogging inside of your exchanger. So if we put the PG in the upstream of exchanger, it is done clearly state that your exchanger will go wrong. Therefore, you have to put the PG at the discharge of the exchanger. And then we have to put also TI in here, because why I put TI rather than TG, because we need to send the signal to the BGS, because the BBGS will consider that or TI and TI in here, because you need to evaluate TI via BPCS, and we can see the leaf temperature that we have. Then we can also put it as the TI in here. So we have to send signal to TI in the central control room. Okay, so the operator can observe via control room that the TI is undergoing for the in problem or in normal condition. Okay, so I think this is the main of our lesson learned for the how to ensure that the backflushing is accommodated in your design in P&ID, and then that all or that instrumentation also have to be addressed in your P&ID review. So maybe in the session I will to share that how to isolate the exchanger. Okay, maybe so we need to put in this one as the blend flying, blend flying is indicated this, and you can find it to 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 ensure that during the online maintenance your exchanger can be taken out in the normal service. And maybe you can just put it as the blind in here. Okay, why we have to put the spectacle blind for the process fluid rather than in the cooling water? Because the main process will happen in your process fluid in here, because this is the process fluid. So I think we don't need to consider to put this spectacle blind for the cooling water session, because it's unuseless for this one. Okay, so I think that's all for this session. Okay, maybe we go to the additional. I will provide you the additional. So okay, so we have two different cases in here, the co-current and the counter current has exchanger. So which one better will give the best performance for your exchanger? Practically and theoretically, the counter current will give the best performance for your exchanger. Why it will give the best performance? Because as you can see here, the counter currents will optimize the hot fluid here. If we compare it to the co-current in here, this one, the TH out is will not be lower rather than the TC out, because this the as the normal it have to differential of the temperature is 10 degrees C, and then as you can see for the counter current, the TC out will have more than the TH out. So I think this is the best performance for your exchanger. This one TH out is still higher rather than the TC out, and for the counter current, the TH out is lower rather than the TC out. So this is the hot fluid and cold fluid. The hot fluid is represented as a process fluid, and the cold fluid is represented as the cooling water supply. So that's why we have to choose, or sometimes or most of the time, counter current will be selected as a part of the best design for your heat exchanger. Okay, I think that's all about my explanation. So how you to design your heat exchanger, and then you can accommodate for the back flushing of your exchanger, and for the instrumentation. So please be note that this material is just based on my personal experience. If maybe it's just different from the other place, because the project specification must be specified will different which for other project, if you comparing to other project, is because the project specification is unique as the owner is different. Okay, I think that's all for my session today. If you have any concern, please comment in the below of this video, so you can share your concern, and then you can ask me through my LinkedIn also. You can find it in the LinkedIn David Wayu Permadi, and then you can share your concern in here. Okay, thank you, bye bye.